Hey, sixth graders. In this video, we're going to quickly summarize what we've talked about over the last series of videos of the three different types of plate boundaries and what's happening and what are the effects of the plate movement at each of those boundaries. And then we're going to talk about one last piece of information for this unit, and that is about hotspots. And so we're going to go through that. And the slide about hotspots is where you're going to take some notes. So here at the beginning, I just want you to be watching and listening and paying attention here. I have a couple of animations and some things to go through and show you to summarize what we've been talking about over the last series of videos. If you haven't already, paused the video to open your doc plate or class notes, plate tectonics 6H. If you need to, pause the video now, open that doc. All right, with that doc open, let's go through, and like I said, this first slide here, there's nothing for you to type. This is just kind of the summary. So on one page here, on one picture, is the summary of pretty much everything we talked about over the last week and a half. This does not exist anywhere in the world where all three of them are just like right there by each other. That would be kind of a crazy location. I would not recommend living there. But you can kind of quickly go through and see, in summary, kind of the big takeaway of what's happening at each of the boundaries. So remember, we have a couple of different convergent boundaries. So over to the left, we'll move from left to right here on this picture. It says when two plates of oceanic crust collide. So you see two ocean plates, right? And so again, because there's at least one ocean plate, in this case, there's two ocean plates. But even when there's just one ocean plate in a convergent boundary, you get subduction. Okay? You get subduction. And so when you get subduction, you get ocean trenches. And whenever you have subduction, you're going to have volcanoes. You're going to have volcanoes. And so since there's no land, there's no volcanic mountains, it's literally islands that have been created because of volcanoes, like Japan. Okay? Not Hawaii. We'll talk about Hawaii today, actually, when we talk about hotspots. Moving to the next one, divergent boundaries. For divergent boundaries here, whoops. Plates are moving apart. Okay, so if you have it happening with two ocean plates moving apart, that's when you get the ridges, and that's really that mid-Atlantic ridge is pretty much the big famous one right through the middle of the Atlantic Ocean there. Okay, and so the seafloor spreads, new material fills in, and it fills in at a faster rate than it spreads, so then it builds on top, builds on top, builds on top, and so you literally get almost like an underwater mountain range when you have these ridges. If it's two plates, like over here, if it's two plates that are diverging and moving away from each other, then you get rifts, and it starts to form a rift valley, and eventually that valley fills with water, and that's where our new where lakes can form, and then eventually oceans. So that's where all of the oceans came from originally. It takes lots of time, though. That is not a fast process. That is really slow. Hundreds of thousands of years to millions of years. Transform boundary. Right? If you're watching this, some class periods we got to the transform boundary notes in class, some we didn't. So if you're watching this, this might be a little out of sequence, and you haven't talked about you haven't learned about transform boundaries yet. But those are the ones that are sliding past each other. They don't create any land formations. They're not creating trenches or ridges or anything like that. The big thing that happens at a transform boundary is that the buildup of pressure and tension as they're sliding past each other is then released in the form of energy, and that would be an earthquake. So earthquakes are the big thing that happen at trench boundaries. I'm sorry, transform boundaries, not trench. Transform boundaries. Okay, and then we have a convergent boundary here where there are two land plates coming together, and if it's two continental plates that come together, the densities are the same, which causes the plates to mainly be pushed upward. Little or no subduction, so we don't see volcanoes, we don't see trenches or anything like that. We see just non-volcanic mountains, just regular old mountains. All right, and that's kind of the summary. What happens at each of those boundaries can be seen with this link here. So I'm just going to kind of walk you through these. These are pretty simple explanations, but you can kind of see them. So there's the transform boundary of them sliding past each other, creating what's called a fault. Okay. Convergent boundary. This is oceanic to continental, so you see subduction, which causes the volcano over here to happen. Here's the trench. Divergent boundary, these two, this is just, they're going to happen at the same time. In the ocean, they spread apart, fills up, and in the land, it spreads apart, creates the Rift Valley. It's the ocean, it's seafloor spreading, eventually creating ridges like the Mid-Atlantic Ridge. Okay, let's keep going. The last part, hotspots. Now, although hotspots are not caused by plate movements, right? Notice we haven't talked about them yet. So there hasn't been hotspot as an effect that has caused any type, a plate movement that the effect of that plate movement is a hotspot, because that's not what's causing the hotspot. But plate movement does have a role to play in this. And so let's go through and talk about it. So hotspots usually happen not at plate boundaries, just kind of in the middle of the plate. And they're an area where we have volcanic activity. The reason for this hotspot is that you get these kind of like passageways through parts of the upper mantle and into the crust that's allowing much more magma to come up through the ocean floor. And it's kind of weird because normally you would see that at a divergent boundary, but this doesn't happen at a boundary. It just kind of happens randomly, usually like somewhere in the middle of the plate. And so that's what we see. And the role that the plate tectonics have for this, though, and the movement of the plates, is that the plate then is going to continue to move while the hot spot stays in the same plate. And that stays in the same exact place. That's really important for you to take away from this. Hotspots do not move. Hotspots do not move. Now, they might appear to us that there's evidence that the hotspot is moved, but that's not what is happening. It is the plate moving on top of the hotspot. I have a video here that I'm going to show you. What happens then is that it can form a chain of volcanoes. Those volcanoes continue to erupt, and eventually, from the ocean floor all the way to the surface of the water, you can create some islands. And the best example of this are the Hawaiian Islands. Hawaii's pretty much in the middle of the Pacific plate. They're there because there's a hot spot. Because of the direction of the movement of that plate, we see these chains of islands that are called the Hawaiian Islands. We're going to do an activity where we look at these a little bit more closely, so I don't want to get into it a lot right now with your notes as you're typing this in. All right, but let's go through now and watch this video here that kind of explains it a little bit better than I'm doing here with some pictures, so you see what's going on and understand what happens over time with the plate movement and a hot spot.
All volcanoes form at plate boundaries. Some form instead in the interior of a plate, where geologists call them hotspot volcanoes or simply hotspots. One explanation of such activity is the presence of a mantle plume, a regionally restricted column of hot rock rising inside the asthenosphere. When it reaches the base of the lithosphere, the rock partially melts, sending intrusions of magma upwards into the plate. Some of this magma erupts to form active underwater volcanoes, or, if activity is sustained, an active volcanic island. An entire chain of such islands forms because the plate carrying the volcanoes moves across the stationary hotspot inside the asthenosphere. This movement slowly carries the active volcano off the mantle plume, causing it to go extinct. A new island grows in its place over the plume.
Okay, so as you're watching this here, he's not talking, but this is what's forming the chain. These previous volcanoes are no longer active. Those are just regular islands. Only the one over the hot spot will have
When the
active
plate
volcanoes.
motion changes, so does the direction of the volcanic island chain. The inactive older islands cool and subside with distance to the heat source and experience significant erosion. With time, former hotspot islands turn into smaller, shallow islands and ultimately become underwater seamounts.
It's going to happen to the first one, which was over here to the left. This shows us the movement of the plate over time. It gives us evidence of, all right, well, this is the direction the plate is moving, because we see the direction of which the islands have been formed. This is a big chain. This is much bigger than Hawaii. Here's the seamount. It's no longer above the surface of the water.
Through geological time, the direction of the plate motion is recorded by this hotspot track of islands and underwater seamounts.
Okay, so there is. Let's get out of there. We don't need that. All right, so hopefully that's kind of showing you what is happening beneath the surface, so you understand what's going on with the hotspot, the plate movement, creating the islands. So lots of people think of Hawaii and they think of, oh man, volcanoes and stuff. Well, there are multiple islands in the chain of the Hawaiian Islands. The Big Island, which is actually named Hawaii, and they just call it the Big Island, that is the only one that actually has active volcanoes right now. All of those other islands, the 4 other islands or 3 other islands, I can't remember off the top of my head, I think it's 4 other islands. Right now, they don't have active volcanoes. And it's because they've moved off of the hotspot. So they once had active volcanoes, but they don't anymore. And we're going to learn more about the Hawaiian Islands when we do our hotspot activity, because I think it's really interesting to use the Hawaiian Islands as the example. Maybe even some of you have gone to the Hawaiian Islands. All right. And maybe because of that, you might have some background information that you can share with the rest of the class. Okay, that ends this PowerPoint. That ends Plate Tectonics 6H. It was a long document that we used, but this document is going to be super important for you as we get ready for our test, which will be in the next 2 weeks, somewhere in the next 2 weeks. Okay, let's do an extra credit right now. See if you actually watched all the way to the end of the video. So if you watched all the way to the end of the video, since this is going into the week of Thanksgiving, Thanksgiving is my favorite holiday. I love Thanksgiving. You don't have to worry about buying gifts for anyone or anything like that. You just go and you just eat really good food, and it's totally cool to eat as much as you want. No one cares. So it's my favorite holiday. What's your favorite holiday? Extra credit, and to show that you actually watched this video all the way to the end, send me an email telling me what your favorite holiday is. All right. If you watch this before Thanksgiving, I hope you have a great Thanksgiving. Otherwise, I will see you guys next time. Thanks.